Current interfaces often require users to switch their attention between two types of screen areas: work areas, in which information is displayed, and control panels containing buttons, menus, and other interactors. Our new interface reduces this effort by taking better advantage of three common skills: the ability to use two hands in concert, as when playing a piano, threading a needle, or typing; the ability to bring tools to our work, as when drafting, driving a nail, or choosing a paint color; and the ability to enhance our view, as when using a magnifying lens to view small objects. You are looking at the screen of a Sun Microsystems SPARC 10 running the Cedar programming environment. The SPARC is equipped with a mouse for the user's dominant hand and a trackball plus thumb wheel for the user's other hand. This region of the screen contains a simple window system that we will use to demonstrate two new user interface techniques: Toolglass and Magic Lenses. Toolglass is a movable, transparent control panel that appears above application windows. We can move a sheet of Toolglass in two ways: by dragging it with the mouse or with the trackball. Using both input devices, we can move a Toolglass sheet and the mouse cursor simultaneously. A transparent control panel enables new kinds of user interface tools. For example, this color palette is a set of buttons called click-through buttons. Clicking through one of these buttons changes the fill color of the object beneath. These buttons work over several applications, including a graphics editor, a rectangle editor, and a text editor. Toolglass requires only coarse positioning with the non-dominant hand. To make use easier, sheets can be scaled up or down using the thumb wheel. A Toolglass sheet can have many layers, called tiles. We can navigate through the sheet by moving to the next tile, back to the previous tile, or use an overview tile to move directly to any tile. A Toolglass tile may contain several tools, perhaps grouped by function. This tile, for example, contains 4 tools used to change the graphical style of an illustration. The line weight tool changes line thickness by clicking through the desired line weight. The line color tool changes line color using click-through color buttons. The fill color tool changes fill color in a similar way. Finally, the font face tool sets the typeface of text clicked through it. Some tiles have several copies of the same tool. For example, this tile contains 2 clipboards. A clipboard can copy an object, move, and paste it somewhere else. Clicking in this little box clears the tool for reuse. Using multiple clipboards, we can pick up several objects to be pasted either into this picture or into another one. These modified clipboards, called rubbings, pick up a shape and then allow its fill color to be applied to other shapes. Using several rubbings, we can capture several colors for later use. The shape in the rubbing reminds us where each color came from. These symmetry clipboards pick up a shape and derive a symmetrical collection of its rotations. We can change the order of symmetry. Then paste one of the resulting rotated shapes. Toolglass sheets can include magic lenses, visual filters that modify the appearance of the objects beneath them. For example, this lens magnifies the objects underneath. We control the magnification with this slider, increasing or decreasing. This second lens is a filter that shows only red objects. Overlapping the 2 filters composes their effects. When we place the magnifier lens over the red object's lens, we see that this little red object is a Time magazine. Magic lenses can be used to modify a scene's appearance in small regions while leaving the rest of the scene alone as context. To move the Time magazine from the kitchen table to the nightstand in the bedroom, we can use 2 different magnifying lenses, one over the dining room table and a second over the nightstand. We then simply select the magazine and drag it from one place to the other. Click-through tools and magic lenses can be combined to solve some problems in graphical editing. For example, if we click here, will we select an edge of the blue square or an edge of the yellow square? A tool containing a lens that shrinks each object around its center makes it easy to click through on the desired edge, for these squares, or for this complex tiling. This lens also reveals how this grid was made, with long lines in the middle and short lines on the edge. Understanding a picture drawn by someone else is often a challenge. Here we use a file-choosing tile to load a picture drawn by our staff artist. What graphical pieces form this picture? To find out, we can use a tool containing a lens that shows a wireframe view, revealing hidden edges. This is also a click-through tool that makes it easy to select previously hidden corners. A reversing tool displays a picture as seen from behind, revealing hidden objects. Tool glass grids can be used to align objects even across application windows. Notice that the tool glass reveals a grid that remains fixed with respect to the underlying graphical objects. Here, the left edge of text in the upper and lower windows has been snapped to a grid line. We can snap the illustration to the same grid line to align the graphics to the text. These tool glass sheets for setting outline colors and fill colors can be composed by overlapping them. The filled triangle in the upper left corner indicates the fill color. The outline triangle in the upper right corner indicates the outline color. Overlapping creates a tool that sets both colors with one action. Magic lenses can be used to preview changes to a scene. For example, this lens can be used to adjust the color of the scene beneath. These controls allow us to change any combination of the hue, saturation, or value of the scene. Because we're using a lens, we can easily compare the original colors with the new color scheme. Another lens shows us an achromatic version of the scene that would appear on a binary display or printer. Another set of artistic lenses affects the geometry of scene objects. For example, this lens applies drop shadows. The depth and direction of the shadow can be varied with this slider. This lens uses graphical search and replace to produce snowflakes out of polygonal structures. This is a map browsing application using an X-Windows prototype of Magic Lenses running under the TWM Window Manager. This map shows a region of Santa Clara County, California. Suppose we wish to see the rivers in Santa Clara County. At this scale, many of the rivers can be seen, but the roads are so dense that seeing the rivers is difficult. To more readily see the rivers, we simply use a lens that accentuates the rivers by de-emphasizing the roads. A map region can be expanded using a magnification lens. Finally, we can apply a lens to the display pixels themselves. This lens performs simple pixel doubling. Magic lenses can be used for visualization. This lens uses pseudo-color to display the Gaussian curvature of this apparently smooth shape. We have introduced the see-through interface. On a movable transparent sheet, see-through tools provide a standard interface across multiple applications, different display sizes, and different tasks. They effectively employ the non-dominant hand, using it as in the physical world to bring tools to the work. The see-through interface can be applied to almost any application, from graphical editing, word processing, and spreadsheets, to scientific visualization and computer-aided design.